Section 7.2, we're back to transformations of exponential equations. So I'm going to write out like the big transformation, what it would look like if everything happened. You know how we did that in everything. And we'll write it down and then we'll do some of the examples. Okay, so this looks huge right now, but the base equation for this, like our normal exponential equation, is like c to the power of x or whatever. C could be any number, right? If c is a whole number, then it's increasing. And if c is a fraction amount, like anywhere between 0 and 1, then it's decreasing. Okay, and then these pieces are all the things that are going to make transformations happen with it, right? Okay, so if we look at A, does anybody remember what happens to the what that number does in the front? Okay, yeah, so it could be like a reflection, right? So if A is positive, we have no reflection, right? It's just a normal picture. If A is negative, then it's a reflection on the x-axis, meaning the x-axis is a mirror and your picture is going to reflect down from that. Okay, so a reflection on x-axis. And so I'll put in brackets. This changes all your y's to the opposite sign. Okay? Opposite sign. Okay, so I know I'm saying it's a reflection on the x-axis, but remember that still changes your y values and it makes your picture look like your x-axis was a mirror and it flips it down. Okay, so that is a lot for just positive and negative for A. And remember, A is also a stretch. So like if A is 3, then that means all your y's are 3 times as much as they were before because your picture is stretching. And if A is like a half, then your y points are half as big as they were before. Okay, so A is also a stretch. Okay, so this A negative and positive, it's only really referring to the sign in front of A, right? And so A is a stretch. So y values get multiplied by A. Okay, so if A is 5, then your y values are 5 times the size. And we better call it a vertical stretch. Okay, so I'm just going to say vertical stretch. So y values get multiplied by whatever your A value is. Okay, this guy was from our standard equation, so he tells us if he's increasing or decreasing, right? C is greater than 1, it's increasing, and if C is greater than 0, less than 1, it's decreasing. Okay, I'm going to write with a different pen just so we don't get all jumbly. Okay, this guy, does anybody know what he does, that B value? Well, this guy's a transformation, the H and the K. The B is a stretch yet, but it's a stretch on your X values. And remember, whatever happens to your X's, it seems to always be the opposite. So if this B value was 3, that means your X's are going to be divided by 3. And if your B value was a half, that means your X values are going to be twice as big. Okay, so this is called a horizontal stretch. And I'll put it as 1 over B, meaning it's going to be the opposite of whatever it is. So change your x's. Okay, also that goes with B is it could be a reflection also. If B is negative, then you're going to have a reflection on your y-axis, meaning your y is the mirror and all your x values are going to change to the opposite sign. So I'll try to add that in here. If B is negative, it's called a reflection on the y-axis. So x's are opposite sign. Okay, so that would just change all your x values to the opposite sign. Okay, and we still need to talk about h and k. It's turning into a map here. So h is your horizontal translation, meaning you're going to move left or right. Okay, and it's the opposite of what you'd think. So if your h is negative, then you're moving to the right. If your h is positive, then you're moving to the left. Okay, so a horizontal translation. So if h is positive, move left. H is negative, move right. And then the last one is a vertical translation of up or down. So if k is positive, you move up. If k is negative, you move down. Example 1 in the textbook, it's on page 349. It says, consider the base function y equals x. Okay, so this is the one that our base that we usually start with, and then we make a table of values from that, and then we transform all the points, and then we draw our new picture. That's how we've been doing them before. So it says, for each transformed function, state the parameters and describe the corresponding transformations. Create a table to show what happens to the given points under each transformation. Sketch the graph, and then describe like the domain range equation of the horizontal asymptote and intercepts. Okay, so they gave us the table here for the first one. Okay, but if we didn't have the table, all we would do is choose x values, right? Like when x is -1, 3 to the power of -1 gives us a third. Okay, x to the 0 gives us 1. Or sorry, 3 to the 0 gives us 1. 3 to the power of 1 gives us 3. 3 to the power of 2 gives us 9. 3 to the power of 27. No, 3 to the power of 3 gives us 27. Okay, so they created this table. Does that make sense how they do it? Just plugging in the x, getting what y is. And then what we're going to do is find out what's happening in here and then make the changes to the points that we have. Okay, so what are the transformations just verbally that are happening here? Yeah, so we have a vertical stretch of 2, right? So that's going to change our y points, timesing them by 2. Yeah, it's an increasing function. Yeah, so we're going to move right 4, and so that's called a horizontal translation. Okay, so now if we were going to make a new table of values, Remember, when we're doing translations, you always do stretches or reflections first, and then you do the ups and downs, lefts or right. Okay, so we're going to do the vertical stretch of 2 first. So that means all your y values are going to be multiplied by 2. So that's times by 2, this, 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 and this. So now we have 1/3 times 2 is 2/3. 1 times 2 is 2. 3 times 2 is 6. 9 times 2 is 18. And 27 times 2 is 54. And then it says we are going to move to the right 4. So that's like adding 4 to all of our x's. So we'll plus 4, plus 4, plus 4, plus 4, plus 4. So minus 1 plus 4 is 3. 0 plus 4 is 4. 2 plus 4 is 6. Am I missing a point here? Oh yeah. So this one should be 4. 1 plus 4 is 5. And then this one was 6. And this one will be 7 then. Okay, so then all we have to do is graph these new points to get our picture. And I don't know if I will graph it or if they will show a graph, which might be prettier than mine. Move that dot. Where are you, graph? Okay. There we go. So these are the points that we found: 3 2/3, 4 and 2, and it's the red picture is the one that's transformed over. And then the question said something about find the domain range equation of horizontal asymptote and intercepts. Okay, so the domain for this one is what? It still looks like it goes here and goes on and on and on and on. So XER. The range still looks like what for this one? Y. Yeah, greater than 0. Because it never goes into the negative and then it cruises up. Okay. What was the equation of an asymptote? So where's the asymptote on here? Where's our picture coming towards but never getting to? Like this line here. Because our picture curves away. So our asymptote is y equals 0. Oh, you were looking at the... Oh yeah, that's where our video ends. There we go. And then, what was the last part we needed? Intercepts? Okay, so is there a y-intercept? Or sorry, x-intercept? So no x-intercept. And then we need to find out where it's hitting on the y-axis, right? And we know that it was what do we know? Hold on. So to find the y-intercept, this was the original equation. So you would go y equals 2, 3, and then you'd put 0 in for x. So y is equal to 2, 3, and 0 minus 4 is just minus 4. So on your calculator, you'd go 3 to the power of minus 4 times 2, and you'll get 0.025, or you might get a fraction of 2 over 81. Okay, so that means that is our y-intercept.